Hi everyone. I am Harsh and I am here to make you guys meet this Nematron Ops Commander. It is an AI incident response system for SRE teams built on NVIDIA Nematron. It analyzes logs, triages incident, recommends fixes, and searches a knowledge base of real outages. Nematron Ops Commander is the AI agent that helps shave off the first 10 to 15 minutes of incident response using NVIDIA's model stack end to end. Nematron Ops Commander is built on NVIDIA Nematron Mini 4B Instruct. As you can see here, it is optimized with SGLang and orchestrate four special agents: log analysis, incident triage, remediation, and performance optimization. The system takes in raw logs and incident descriptions from real incident as form of like an incident corpus and returns structured, actionable outputs, including severity, evidence, root cause, and next step, not just chat text. So let's get into the demo right away. The essential first step that I want to show is the knowledge search. Let's say this system is meant for SREs. So SRE wants to talk about some failure that it is going through and wants to read docs online. It can basically, let's say it asked about OOM killed memory limit in Kubernetes. It immediately links it up to Java. And from Stack Overflow, it gets the resolution and basically the related any like service or like since it's Kubernetes, so you can see it's talking about Kubernetes here. Let's say it has another query about EKS autoscaler max size reached pending pods. So you can see that it is a autoscaling issue. So we can see since EKS maps to AWS, so it pulls up results from the AWS docs and so on. If you like talk about AKS node pools, then it'll be like talking about Azure, and then it'll tell you resolution like temporarily adjusted core DNS PDP. This is what somebody did. And like you can also basically paste production level logs to it, and then based on it like ask it to basically let you know as to what is the root cause and the resolution of that particular failure. So it'll extract the findings from previous logs and it'll give you the um, n- recommendation, next steps, and some evidence as to why it thinks that this should be done. You can also paste in some other logs. For example, you can basically give it logs from your production system. It does the job of like recognizing the severity, the service you're talking about, and then basically from its incident corpus, it is in the capacity to reply to you with the next step. Um, so basically this you can see that it has given you like the priority of the fix and basically critical failure, which is API gateway auth failure. As you can see from this logs, there will be authentication related issue. So root cause it has determined and given the next steps for the user. So basically, it takes those raw logs and produces structured finding, as you can see. So it is in free text. It is schema validated output designed for automation. Same way, there's a triage agent which like lets you basically tune how much errors you are facing, what is the latency you are facing overall, and then it will also not just tune ask you to tune the knobs, but it will give you some actionable uh, insights into what you can do as next steps, and basically some recommendation to the SRE what it can carry out. So you can see next steps are here, what should be their priority of dealing with it, and basically what's the steps, actions they can take. And then same way, like let's say there is another ticket related to DNS resolution, so the SRE can basically paste that title of the ticket here. It'll take automatically, if you like link it up with your overall system application, then it will link it from there. And then you can just basically allow it to run. And basically these toggle, these bar is just I'm using because I don't have matrix for the graph right now. But once you provided that, I'm pretty confident it will be able to just like take it automatically from the dashboard and give you the next steps, actionable ones, as you can see here. Like it's giving you the affected service and next steps. Now coming to the performance optimizer, in this one it basically takes the matrix from your system and then tries to give you some actionable insights like increase GPU memory, optimize the batch size, auto scale limits, and basically give you the risk of those as well. So it detects bottleneck and propose risk aware optimization. And like for this one also, it's from the dashboard you can like tune this. And let's say in this case the severity was high because memory usage and all was pretty high. But if it is low and like there is some minor error, then you will see here that for the performance optimizer, like let's say there is just like a production inference, that let's say there's a Java service with uh, this and OOM kills during this. So you can see that for OOM kills, the uh, priority severity is still high, and then it's recommending these steps. And finally, I want to conclude by saying here that NemOps is not just your simple chatting based system. It is actually helping you make decisions. And NemOps Commander is not just for a demo, it's for a direction. And modern AI infrastructure doesn't fail because we lack matrix. Uh, NemOps is my attempt to basically help systems succeed, which basically is driven from the real GPU failure knowledge, ECC degradation, NVLink fault, thermal collapse, PCIe power loss, and turns it into agentic reasoning loop that can observe, diagnose, and act. So Nimitron was the right model here because it basically is structured tool calling, reasoning traces, and local execution, which are non negotiable infrastructure systems. And the other thing that I'm proud about here is that it can basically run locally as well. If you like set up all the indexing and the server system, you can basically run it locally, that you have the data, and then you can just see your live GPU status, ask it questions. It will come out with the analysis of it in depth. So like let's say I were to ask it like check the health of all GPUs and tell me any issues. So you can see it's running on the system right now. So it here you whatever you're seeing here is just running locally. So essentially you can see that it is giving like a dashboard to the user. And um, you can basically only you need 16 GB of RAM. And you can use Olama to download the Nimitron model, which is just a few gigabits, and all inference happen on your machine through the local API. The agent loop, tools, RAG index, and UI are local Python, so they share no external API calls. And you can see that like once you ask it some question, it basically gives you the result after scanning through all the GPUs here. And basically you can see that the any issues that it found related to temperature, clock speed, fan speed, uh, any diagnostics that it is suggesting to run will be said here. And you can set up alerts on your system as well. And this is basically stemming up from my previous experience at Microsoft, where I built GPU telemetry platform that processed 10 million events a day and predicted hardware failures. NemOps is that operational experience, open source and encoded into an agent. My belief is simple: the future of AI infrastructure isn't dashboard, it's reasoning systems that operate alongside us. NemOps is one example of what future can look like with NVIDIA Nematron. Yeah. So this is a fully incident response pipeline powered by Nematron, optimized for NVIDIA hardware. It's open source, production ready, and built for real SRE workflows. Thank you.